Hi guys, we are students from Unifaith. Our majors are Electrical Engineering and Control and Automation Engineering. We are going to present to you how a radio works, showing its circuit and components. Have you ever been in a car listening to some music and thought, how this radio works? So, we will explain to you. There is a clash as to who really is the radio inventor. In 1893, the inventor Nikola Tesla demonstrated a wireless radio in St. Louis, Missouri. Despite this demonstration, Guglielmo Marconi is the person most often credited as the father and inventor of the radio, when in this clash. Now, we are going to explain the radio components. Resistor makes the current flow harder. Capacitor stores energy in the form of an electrical field and helps the filtering process. Transistor, responsible for the signal amplification. Potentiometer, it's a resistor in which we can adjust its value. Inductor, stores energy in the form of a magnetic field. Diode, it works like a key that can be open or closed. Variable capacitor works like a common capacitor in which we can adjust its value. Antenna, it's responsible to receive the signal. Before start to explain the radio circuit, we are going to understand more about the waves. AC waves are sine waves, as you can see in the figure, and are characterized by the frequency, which is the number of cycles per second. This way, you can see that the first wave has a higher frequency than the second. DC waves are continuous sine waves, have a constant value, not depending on the frequency. Now you can see the radio circuit. The radio circuit can be divided in 4 stages. The first stage is the antenna, that captures several signal types that have different frequency. The red signal on the graph represents a wave that is formed by several waves with different frequencies and amplitudes coming from the environment. The second stage is responsible for filtering the red signal. After the red signal passes through the variable capacitor and inductor, he becomes the green wave, represented in the figure. We can note that the variable capacitor and the inductor act by excluding waves with frequencies outside the desired range, only allowing the passage of waves that fall within their operation range. The variable capacitor is represented in the circuit by C1 and C2, which have different operation values, and they are activated by switches S1 and S2. The third part is responsible for the signal rectification. The diode acts by excluding the negative half cycle of the wave that becomes a pulsating AC signal. The wave in question is represented in the figure by the blue wave. Finally, an amplification step is made to obtain a signal gain through the voltage applied to the transistor. Note that the pink wave has a much larger value than the previous ones. Briefly, we can represent all the waves in a single graph. As it was possible to observe, the radio has a circuit capable of absorbing electromagnetic waves and turning them back into sound waves. And now you can see the real circuit. The actual circuit works as explained above. In this case, a DC source was used to power the circuit, and the function generator to simulate the incoming waves to the antenna. Note that the waves shown on the oscilloscope are similar to those already shown. This is all, guys. Bye bye, and I hope that you enjoyed.